Today we'll discuss the expansion of expand 1 by 1 minus 2x 1 plus 3x in a series of ascending power of ascending powers of x and find when the expansion is valid. Excuse me, class. See here we are doing three things. First, we are expanding. This is number one. In the ascending power of x and show that the expansion is valid or not. But to expand, first we have to reduce into partial fraction. Then expansion formula will apply and apply. So three things we are doing here. So first we will go for partial fractions. So solve 1 by 1 minus 2x 1 plus 3x. Result into partial fraction a by 1 minus 2x b by 1 plus 3x. Taking LCM 1 by 1 minus 2x 1 plus 3x. If you take the LCM 1 minus 2x 1 plus 3x. So a of 1 minus 2x will go up. So this is 1 plus 3x. B of 1 plus 3x, this go of 1 minus 2x. So denominator same, cancel. So we are left with 1 equal to a of 1 plus 3x, b of 1 minus 2x. Now what we are doing here, suppose if x equal to 0. If I take x equal to 0, this is 0, this is 0. So a plus b equal to 1. One equation we got. A plus b equal to 1. Suppose if x equal to 1 by 2. If you substitute, let me change the color and show you. If we take x equal to 1 by 2. Here if you take 1 by 2, here if you take 1 by 2. So 2 getting cancelled, 1 minus 1 is 0. So b is 0. So we are left with 1 equal to a plus 1 plus 3 times 1 by 2. So this is equal to a equal to 1 plus 3 by 2. So this is 1. This is 1 equal to a of, you see if you take the LCM, 2 plus 3 is 5 by 2. So if you cross multiply, 2 by 5 equal to a. So in this equation, we are putting equation number 1, call it equation number 1. So if you put a is 2 by 5, 2 by 5 plus b equal to 1 implies b equal to 3 by 5. So now what is our equation? 1 by 1 minus 2x 1 plus 3x equal to a by, what is your a? 2 by 5 by 1 minus 2x. What is a b is? B is 3 by 5. This is b, not 13. It looked like 13, but it is b. This is b, please. So 3 by 5, 1 plus 3x. This thing, here what we are doing, 2 by 5, 1 minus 2x whole to the power of minus 1 plus 3 by 5, 1 plus 3x whole to the power of minus 1. Because we are taking to the numerator. 2 by 5. So if you expand this thing, this will be 1 plus 2x plus 2x 2x 2x, 2x square plus 3x, 2x square, 2x cube plus so on, 2x to the power of n, so on, plus 3 by 5, 1 plus 3x, 3x square, so on, 3x to the power of n, so on. You see, 1 plus is there. If minus is there, plus minus will come. If plus is there, this will be alternate. This will be 1 minus 3x, 1 plus 3x, minus plus. Let me change the color and show you because it doesn't make a sense. So this is, it should not be plus, it should be minus. This is plus, minus, plus. This is minus 1 to the power of n. Because if one minus is there, all will be plus. If plus is there, alternative plus and minus will come. So 2 by 5, if I take 2 by 5 common, from here 3 by 5 plus 2 by 5 summation 2x to the power of n plus 3 by 5 summation minus 1 to the power of minus 1 to the power of n 3x to the power of n. 2 by 5 by 3 by 5 is 1. 1 plus 1 by 5, 1 by 5, 2 if you take on or inside in the summation, 2 to the power of n plus 1, x to the power of n plus 1 by 5, summation minus 1 to the power of n, 3 to the power of n plus 1, x to the power of n, x to the power of n. So now what we are doing next? Next, writing common. So this will be 1 plus 1 by 5 summation 2 to the power of n plus 1 x to the power of n. X to the power of n I will take common. So none plus 1 plus minus 1 to the power of n, 3 to the power of n plus 1 x to the power of n, x to the power of n. So this we got. Now this is x to the power of n. Expand in the ascending power. Now we have to find expansion is validity of the expansion. Expansion is valid. So here 1 minus 2x to the power of minus 1. Here mod of 2x should be less than 1. This implies x is less than mod of x, positive value of x, less than 1 by 2. And another expansion is 1 plus 3x to the power of minus 1. This equal to 3x less than 1. This implies mod x is less than 1 by 3. So therefore, the given expansion is valid when mod of x is less than 1 by 3. That's it. Next, second problem, one more problem I want to do. Find the coefficient of x to the power of n in the expansion of x plus 1 by x minus 1 whole square into x plus 3. So this first we have to resolve into partial fraction. Then we can find x to the power of coefficient of x to the power of n. So x plus 1 over x minus 1 whole square into x plus 2. This is a by x minus 1, b by x minus 1 whole square, c by x plus 2. Now taking LCM, x plus 1 divided by x square minus 1 whole square x plus 2 equal to, if you take the LCM, this is x minus 1 whole square, x plus 2. So this is a of x minus 1, x plus 2, b of x minus 1 whole square is gone. So x plus 2, c of x plus 2 is gone, x minus 1 whole square. If you want all the types of these expansions, I have done one more video. You can go for that. But here, so x plus 1 equal to a of x minus 1, x plus 2, b of x plus 2, c of x minus 1 whole square we got. Now what I want to do is, if x equal to 1, if I take x equal to 1, what will be the result? You see, if I take x equal to 1 here, 1 minus 1 is 0. Here 1 minus 1 is 0. So only we will get b. So x equal to 1 if you write. So this will be 1 plus 1 equal to b into 1 plus 2. b into 1 plus 2. b into 1 plus 2. X equal to 1. So 2 by 3 equal to b. 2 by 3 equal to b. Suppose if x equal to minus 2, if we take this minus 2 plus 2, this minus 2 plus 2 is gone. So here minus 2 plus 1 equal to c of minus 2 minus 1 square. So minus 2 plus 1 is minus 1, minus 1 is minus 3, whole square is minus, so minus 1 by 9 equal to c. Minus 1 by 9 is equal to c. Now we have done a and we got a and 1, we want a. Oh, we got b and c, we want a. Now equating the coefficient of, next equating the coefficient of, now equating the coefficient of x square. Equating the coefficient of x square. You see here, equation coefficient is 0. This is x into x square. This is c square. A plus c equal to 0. A plus c equal to, a plus c equal to 0. So what, a plus c equal to 0. So what is our a? A plus c equal to 0. We don't know a. So minus 1 by 9 equal to c. Minus 1 by 9 equal to c. Minus 1 by 9 equal to c. So this implies a equal to 1 by 9. So what is our expression? What is our expression? X plus 1 by x minus 1 whole square into x into x plus 2. X plus 2. X plus 2 equal to a is 1 by 9. 1 by 9 of x minus 1 by x plus 2. Oh, no. Now this one. So x minus 1 whole square, x plus 2. X plus 2. So a is 1 by 9. So c is minus 1 by 9. And what is our b? B we have to find. We got b equal to 2 by 3. b equal to 2 by 3. So now this is 1 by 9. If you take minus common, 1 minus x to the power of minus 1, 2 by 3, 1 minus x whole to the power of minus 2, minus 2, minus 1 by 9. If you take 2 common also, 2 common also, 2 if you take common, 1 plus x by 2. If you take to the numerator, if you take 9 to the, if you take this to the numerator, so this is 1 by 2, 1 plus x by 2 to the power of minus 1. 1 plus x by 2 to the power of minus 1. So now expansion minus 1 by 9. 1 minus x is 1 plus x square plus x cube, so on x to the power of n, so on. Then 2 by 3. This is power 2 is there. So it will be 1 plus 2x plus 3x square plus 4x cube, so on, n plus 1 x to the power of n, so on, so on. This is minus 1 by 9 to the 18. So 1 plus is there, so plus is there, so minus will come. 1 minus x by 2 plus x by 2 square, so on, minus 1 to the power of n, x by 2 whole to the power of n, so on, so on. So now we want coefficient of x to the power of n. So this is minus 1 by n. What is the coefficient? This is 1 by n. This is x to the power of n is 1. So plus 2 by 3, 2 by 3 n plus 1 plus no minus 1 by 18 minus 1 to the power of n by 2 to the power of n. So we can simplify minus 1 by n, 2 by 3n plus 2 by 3 minus 1 by 9 minus 1 to the power of n minus 1 to the power of 2 to the power of n plus 1. This we can simplify. So this we can simplify minus, so if we multiply by 3 by 3, this is 9, this is 3 to the 6, 1 minus 6 is 5 by 9, 5 by 9, 2 by 3 n plus 1 by n minus 1 to the power of n plus 1 divided by 2 to the power of n plus 1 is the coefficient of this. Okay, this is the problem we have done. So we have done two problems. First, there are three steps. First, expanding. How? First, we have to resolve into partial fraction, then expand it, then find the coefficient of n. The same thing we will do in binomial also. So please subscribe my channel. Thanks for watching. Thank you.